When working with a program like Maya, we've seen that very quickly we can end up with many objects in the scene, which necessitates some sort of organization method. In 3D graphics, this is usually accomplished by a data structure called a scene graph. Now, a scene graph is essentially just a hierarchical organization of each component present in the scene. Now, we're going to need an example to look at here, so in addition to these hidden default camera objects already present in the scene, I'm also going to go ahead and add a cube, and I'll also add a sphere, and I'll move that off to the side just so that we can see both objects. Now I'm also going to click and drag with the middle mouse button. I'm going to click and drag on the sphere and drag that on top of the cube, creating this sort of hierarchical structure. Now, if you've done this before in Maya, then you'll know that, when we move the top level object, which is the cube in this case, well, the sphere or whatever object we have listed kind of beneath it, or we could say as a child of it, that object is going to move as well. It's going to follow it around. No matter what transformation we do or we perform on the higher level object. So let's examine this in a bit more detail and see what exactly is going on here with this hierarchical structure, or in other words, this scene graph. So in Maya, we can view the scene graph, or again, this hierarchical structure, using something called the hypergraph. So we can find that under Windows and General Editors. I'm going to go to the hypergraph here and choose the hierarchy view. We'll talk about the connections in just a second here. So this is the default view inside the hypergraph. You can see that, even if we have all of the objects selected through the outliner, and then go ahead and click on this scene hierarchy button, which is used to just show the selection in a hierarchical view, we still can't see those hidden objects. So let's just go ahead and enable a few extra things here inside the hypergraph. Let's go over to options and display, and I'm going to enable hidden nodes just so we can see those hidden camera nodes as well. So that's nice to see there. And we're also going to go and enable shape nodes as well. We'll talk about shape nodes in just a second. All right, so every box inside the hypergraph here, each one of these boxes represents what we call a node, right? I've already been using that word a number of times so far in explaining this example. And a node is just a collection of data, right? And these different types of nodes give us different information to work with. Now, we can kind of think of like a hidden node at the highest level in this scene graph. We don't actually see it here, but we can think of all these top level nodes as the child of one main root node. And that root node is the only node which doesn't have a parent, right? It's at the highest level of the hierarchy. All the rest of the nodes, right, as we've seen, just these cameras, for example, and the cube itself is hierarchically arranged as children of the root node. And these child nodes can have children of their own, right? And those children can either be something like a shape node, which we'll talk about in a second, or even another entire object. We'll see that the entire node structure, there's these two nodes related to the sphere object. Both of those are arranged as essentially children of this cube object. All right, so the hierarchies we see here dictate how certain transform nodes affect their child nodes. Okay, so right, we've seen that each object has mainly has two nodes representing it. So what's the difference between them, right? So in the most basic sense, let's start with a polygon object such as this sphere. A polygon object is, again, in its most basic sense, composed of two nodes. In fact, just to make this easy to understand, let's make a cylinder. Just so we're not dealing with this sphere that's a child of the cube. All right, let's just think about the cylinder for a second here. So for the cylinder here, right, we have the two nodes making up that object. This higher level node is called the transform node, which stores the translation, rotation, and scale of the object in world space. Now the shape node, on the other hand, which is this child of the transform node, this stores all the polygon components so for example, like vertices with position vectors specified in local space. Or in other words, relative to the object's pivot. Or we could think about that as the origin of this local coordinate system. And we can actually see this whole idea of like the shape node's components being specified relative to the parent transform node by simply taking any shape node and actually parenting that to a different transform node. So let's, here we have one cylinder. Let's actually duplicate that. I'll move that over to the side here. I'm just going to make a simple change to that object. Make it more shaped like a cone, just so we can tell it apart from the other object. And we're going to have to use a special command in order to actually reassign shape nodes. Let's enable shape nodes in the outliner, actually, just so that we're able to select them easier. We could do it with the hypergraph. Sometimes you don't have this window open, actually. Which, right, and usually we have the outliner open anyway, so we might as well just turn on shape nodes under the display menu here for the outliner. All right, we can expand both the cylinder 1 and cylinder 2 and see the two shape nodes here. All right, so let's leave that shape node in there for a second. But what we're gonna do is take the shape node from the second cylinder and assign it to the first cylinder, okay? And we're going to need a special line of code in order to do this. Let's just open up the script editor here. I actually already have it written out in Python. That will be, just either import your Maya commands as CMDS or whatever you want to call it, or you can just access maya.cmds.parent and then specify two arguments here, right? We need to set relative equal to true to just take care of the, any transformation that was applied to the object. And we need to set shape equal to true, which will parent, right, the shape node of, whatever shape node we have selected, as opposed to parenting transform nodes, which is usually what happens here, right? Right. If we have one object selected, then select another, and just hit P, and arrange them as this hierarchy that we see. That's parenting basically one transform node under another transform node. That's not what we want to do here. Instead, what we want to do is, let's bring back our shape nodes. We want to parent one shape node under another transform node. So I'm first going to select this kind of modified cylinder that I just made, and then I'm going to control select the other transform node here, and I'm going to run this line of code. And so there we go, right? So that has taken the second cylinder shape node here and actually added it to the list of shape nodes being controlled or being positioned by the cylinder 1 transform node. And look at what happened here, right? Let's undo, right? So originally the second kind of this modified cylinder cone shape was positioned over here, right, according to this transformation, about 8.1 on the X, 0 on the Y, -4 on the Z, right, that was the transform that we had specified using the transform node. But according to the shape node, these vertices are, they're just positioned at some offsets from the origin of their local coordinate space. When we take those components and go ahead and have them specified in relation to the origin of local space of another object, say for example, P cylinder 1, well, physically the components are actually going to move in world space, right? Because they are now positioned relative to another transform node, right? And that other transform node is positioned somewhere entirely different in world space. All right, so very important to make that distinction and understand the difference between a transform node and a shape node, and just see how shape nodes actually work and what they actually mean. All right, so we can, let's leave up the script editor for a second there. I'll just bring back up the hypergraph so that we can again see what our scene looks like in perhaps a more understandable hierarchical view here, right? We can see the changes we've made. We can see the two shape nodes kind of parented underneath this single transform node. This P cylinder 2, this is actually just an empty transform node. It's just a transform node. Even look at where our transform widget is positioned in world space here. We can see the widget kind of just floating out in empty space with no geometry attached to it. So that's what a transform node is all on its own, right? When we don't have any shape node with which to visualize it. All right, so that's just kind of an empty transform node, not doing anything for us anymore. So maybe let's go ahead and delete that. But it was interesting to see actually that empty transform node. And let's just examine something else very interesting actually about groups in Maya, because a group is basically nothing more than just a transform node, kind of like that empty P cylinder 2 that we had just floating around there, right? So let's go ahead and add another. Maybe I will make a cone primitive. Kind of put that over here. Let's select these two objects, the cylinder and the cone. I'll do a Control G, group those together, right? Maybe we're used to seeing this sort of structure in the outliner. We can also look at it in the hypergraph, whichever you're more comfortable with. All right, so we can see the two transform nodes. The cone and the cylinder parented under the group, which is just another transform node. And of course, all those shape nodes are still there, parented under the cone and the cylinder transform nodes. All right, so it's, again, very, very important to note that a group is just a transform node. Let's just do a couple other things with this to get comfortable with it. Let's go to the create menu. Let's create an empty group, right down at the bottom of this list is empty group. So we can see that creates a new transform node called null. Maybe we can move it over here, and let's reparent a few things, right? So we can select another, maybe the cylinder transform node. And then shift select, let's see, that will have to be a shift select to select it in the hypergraph, and go ahead and hit P. And what that is going to do is, again, parent that cylinder under the empty group. That's another way of grouping objects together. We could manually parent things, one at a time. To another empty group node. But yeah, just important to remember that groups are just transform nodes. We can create empty groups. We can use empty groups if we have them left over from something else. If they just contain some transform. We can use them for another purpose. We can even take, maybe let's do one final thing here with this mess of nodes that we've created. Maybe let's take that second cylinder shape that we were previously working with, and I'll shift select the group one node, again selecting it through the hypergraph, and let's just run that line of Python code again, which essentially parents that cylinder shape under the group node, right? But by default, a group node is created just with a transformation sitting at origin, with its transformation, zeroed out, just sitting at origin. So we can see that, the shape for the cylinder has kind of jumped over and is now specified relative to origin, right? That's the new, that is where the origin of the object's local coordinate space is now positioned. So, we've kind of built a new polygon object out of other components, if you will, right? Just using a group as the transform node and taking the shape node from another object. So kind of interesting. Just to see how we can mess around with the scene graph and kind of restructure things as we wish. All right, let's get rid of those objects. We don't need those anymore. We can also get rid of that empty group, that null, the object named null. You can get rid of that for a second. And just before we finish off with this hypergraph view, we'll also take a look at the connections view. Select everything, and we're going to hit this other button here right up at the top, input and output connections. This is another way. Of kind of visualizing the scene, it's not really a view of the scene graph, but it's a view of attributes that are connected to other attributes. So you'll notice here that we don't actually see the child-parent relationship between the sphere transform node and the cube transform node. Instead, what we're seeing here is the fact that there are actually attribute connections between them. So this is another view of things that are connected to each other, but it's not hierarchical. So somewhat related to the scene graph, but not really a view of the scene graph itself in a hierarchical sense. Right, and we can see the cameras listed here as well. Again, without really any sense of like what is parented to what, because all we're seeing here is just like camera shape nodes alongside camera transform nodes, and we can't really see a relationship between them, right? But I guess what we can see here is the fact that the input or the kind of like the geometry creation input node, we can see that is still connected to the shape node. Just because we haven't cleared construction history yet, this node still exists. All right, let's get rid of the hypergraph and actually take a look at a newer tool or connection viewing tool that was added to Maya a little bit more recently. And that'll be under Windows and the node editor. Let's take a look at that. Right, if you've used the Hypershade in Maya for material editing, the node editor should look familiar. But this is just not built for shader manipulation, but rather for just visualizing other attribute connections inside of Maya. So we can always hit the kind of clear graph button, and then we can go ahead and select various objects and click on the input and output connections to see everything that's connected to the selected objects and everything that those objects are connected to or outgoing connections, right? And we see the same view here, right? We see these two incoming, right? The polycube node, the polysphere node, again, just those geometry creation nodes connected to the shape nodes, which are connected to this shading group. And we can also see the transform nodes, which they were selected, but there's no technical attribute connection here. It's really only the transformations of these nodes that are like applied to the shape nodes through the scene graph, right? It's not like a Maya attribute connection that causes that to happen. All right, we can do our edit delete by type history, right? Which would delete those two incoming geometry creation nodes. So we can see that those have disappeared. Kind of interesting. And maybe we'll do one last thing here. Just by expanding, hitting this little kind of hamburger menu looking thing on the cube transform node as well as the sphere transform node. And let's see, what will we do here? I'm actually gonna go Shift P. I'm gonna select that P sphere 1 and hit Shift P to remove it from the hierarchy. Again, remember what I just said. We can create connections between different attributes, which are a different process than the scene graph hierarchy, where higher level transformations are applied automatically to child objects or child transform nodes. We can actually get rid of that hierarchical organization here and simply, specify a custom attribute connection, right? Let's do something kind of interesting. Let's maybe connect the translation of the cube to the how about the scale of the sphere? So the sphere should disappear here because the cube starts at 0, 0, 0. So if you can imagine 0, 0, 0 being copied over to the scale attributes of the sphere, it should disappear, right? It should be set to just zeros on all axes. It should just completely disappear. And by moving the cube, right, by specifying X, Y, and Z translations, we can have those values copied over. Again, because of this connection we've specified, they are copied over to the scale attributes of the sphere transform node, and we can see those changes taking place. So, right, let's just be clear on the difference here. This effect that we're creating here has been created through specifying actual attribute connections. This is not being caused by the scene graph transformation hierarchy. All right, so we're done with this example for the time being. Let's close the script editor as well. And let's just look at one more really helpful way to kind of understand this hierarchical structure and the way the scene graph works. One specific way that the scene graph is utilized for organization purposes is when creating joints for a rig. All right, so let's go to top view here and let's just go to skeleton, the skeleton menu, and let's create joints. I'm just going to drop down a few joints here and hit enter. All right, so there's a couple joints. So notice the hierarchical structure that has automatically been created here for these joints, right? Starting with the first joint, every sequential joint is actually a child of the previous one here. And so these transformation dependencies, if you will, these dependencies that we're used to expecting when it comes to joint chains are actually a result of these joints being arranged according to a transformation hierarchy, right? The exact way that the scene graph actually works. So let's go ahead and create another joint chain. Put that one over here. Just throw down a few more joints, hit enter. And what we can do is actually just alter this hierarchy the same way we would parent other objects or other transform nodes to other transform nodes. Again, we saw that in order to work with shape nodes, it's a bit of a different process. Could use a special command for that. But what we can do here is maybe take, how about this new, the root of this new joint chain, and select, again, in the outliner, I have to use Control to select the transform node I want to parent it to. And we can hit P and specify a parent relationship there. So we can see that joint 5 has now been, organized as a child of joint 1, right? So now they all will follow if we go ahead and transform that root node. All right, so that's kind of interesting to see how joints behave. And just to finish off with this topic and drive the point home, but the difference between transform nodes and shape nodes, let's just understand that, in keeping with the whole idea of a joint system or a rig, all these joints do for us is just specify transformations in 3D space. They have no visual appearance that we can render. And so what we can actually do if we wanted to, maybe as placeholders or as a way of, being able to select the joints with other shapes instead of just hunting around for these tiny little circles and lines in the 3D scene, we can actually parent other shape nodes to the joints themselves, which are transform nodes, essentially. So let's go ahead and do that. How about we create a cube? All right, I'll just move this cube over to the side here, and I'll bring up the script editor again, so we have that line of code ready to go. Let's select the cube shape, and I'll go ahead and parent that to, how about joint 7 here? All right, so again, the object should just jump over and be, appear to be connected to the joint itself, right? Because the geometry of this cube was specified, just a few units. Each vertice was just positioned a certain amount on either side of the origin of its local space. So if we just specify those positions relative to the joint's origin, right, in relative to a new local coordinate space, the entire object should move. So that's kind of cool. We can see that geometry kind of following the joint around. So it's a nice way of kind of maybe visualizing the joint, or using it as placeholder geometry, something like that. And we can even use curve objects. So let's use the curve tool here. I'll just create a few NURBS curve line segments here. I'll just leave that there. Actually, we can move this wherever we want, as long as they are specified, kind of more or less surrounding the pivot of the object. And NURBS objects have shape nodes as well, specifying the curve points. And so we can just go ahead and let's parent that to joint 6. Let's parent this shape node to joint 6, and that should jump over there and give us an alternative way of maybe selecting that joint, right? And this is actually sometimes used to actually make joints easier to select with like an FK rig or something like that. All right, so there's a quick overview, or maybe not so quick overview of the idea of the scene graph, the hierarchy that it presents for us to work with, and just some of the things we can do inside of Maya to work with that hierarchy and really alter it to do whatever we need it to do.